Baik, terima kasih. Hadirin yang saya hormati, selanjutnya kita akan menginjak kepada pembicara berikutnya. Ya. For the next session, we invite person who is really involving in the development and delivering the artificial intelligence and data science solution. He is Todd Mostak, the founder of and CEO of OmniSci. He has a solid educational background in this area, as well as industrial experience. Please welcome Mr. Todd Mostak.
Hi, thank you so much, Salamat. Thanks everyone for having OmniSci at this illustrious conference. It's really an honor to be here.
Yeah, okay. Before you are giving your keynotes,
yes,
please allow me to introduce first, Mr. Okay, please the video, Mr. Todd Mostak, the founder and the CEO of OmniSci, an open source accelerated analytics platform. Mr. Todd received the idea of using GPUs to accelerate the extraction of insight from large database set while conducting his Harvard graduate research on the role of Twitter in the Arab Spring. Frustrated by the capability of conventional technology to allow for the interactive exploitation of this multi-million row dataset, Mr. Todd built one of the first GPU-based database. Upon completing his study at Harvard, Mr. Todd joined MIT as a research fellow at the Computer Science and Artificial Intelligence Laboratory, focusing on GPUs, databases, and visualization, before founding a company in late 2013. Mr. Todd received his undergraduate from the University of North Carolina at Chapel Hill in the economics and anthropology. The next 20 minutes, please welcome Mr. Todd Mostak to deliver your speech. Please.
I was on mute. Thank you, sir, and Salamat, everyone. Thank you for having us. It's really an honor to be here, and apologies for jumping the gun before. So now,
it's okay, no problem.
Let's see here. Can everyone see my screen okay?
Yes.
Oh, great.
Please start your, okay. Thanks,
awesome.
Mr. Todd Mostak.
Well, thank you for that very, very kind intro. Again, just terribly excited to be here and tell you about something that's very near and dear to me personally and us as a company, which is the power, the transformational power of accelerated analytics. And just as a little bit of a segue into how we got here, how we started as a company, and why I originally started to build the product, it came out of my own personal pain point. But before that, I was actually on a plane to Aleppo, Syria. After I graduated my undergraduate studies, I wanted to see the world a little bit, and short of teaching English, I didn't know quite how to do that. So I started looking at jobs teaching English abroad, and there were probably more jobs in Asia, maybe South Korea and China, but one stood out that I found on the website Craigslist, if people are familiar with that, and it was to teach English in sunny Syria. So I didn't know a terrible lot about the region, right? Obviously, the Middle East has always been a fascinating historical and cultural place, I think, for a lot of people. But I think I was pulled by the sense of adventure, and soon enough I was on a plane to Aleppo. And to fast forward, I was a little homesick at first, but fell in love with the language and culture, and started learning Arabic. Continued studying in Damascus. Was about Syria for about a year, and then I got a fellowship from the U.S. State Department to study Arabic at the American University of Cairo in Egypt. And so, by that time, my Arabic was pretty decent, particularly written and listening. And I actually worked as a translator for a bit before coming back to the US and doing my graduate studies on the politics of the region at Harvard. And so, armed with that, as soon as I got back, this was 2010, the Arab Spring happened. And people probably remember the revolutions that rippled, starting at Tunisia and through Libya, and then obviously Egypt and Syria and other countries. And nobody really quite knew what to think about it. It was a big change in the region. And I immediately thought, people were talking about Twitter and other social media sources as a catalyst for the Arab Spring, and people talking about where the protests are. But it's also an unprecedented source of data to understand what people are thinking and saying, when they're thinking and saying it, and often where. As many of these tweets were geocoded from people's the new smartphones that people were actually starting to buy at that time. And so I said, I had a bit of background in comp sci. It's a longer story, but I did have a few CS courses under my belt. So I started harvesting all this data on my workstation. And soon enough, it wasn't a massive data set. You have to remember this is 2011. And the latest big data technology then was still Hadoop. Spark was just barely on the horizon, if at all. And so I tried to start analyzing, hundreds of millions of geocoded tweets on this workstation. And, I was doing NLP analysis about the sentiment of what people were saying about the revolution. I was doing graph analysis of who people were following on Twitter. And then I was even doing demographic analysis by correlating, where do people tweet at night? And that's probably their home kind of census block, if you will. And I got some census block data or census district data from Egypt and was looking at doing demographic analysis. So did people in more urban or rural areas, did richer or poorer areas, did they support or were they against? So it became this big data problem. And I found very quickly that the conventional tools at my disposal, and that's open source databases like Postgres, that was Esri, that was things I was writing in Python and eventually in C. None of it was really up to snuff. So I have these burning questions and want to probe this data, but basically found that my analyses would take hours, if not days, to run, or they'd run out of memory, which was worse, and I'd have to start all over. So it was an incredibly frustrating experience. And essentially, and sorry if you guys hear my kids calling, they're getting ready for bed. Such are the times that we live in. But the gist of the story is I was so frustrated because I had all these burning questions to ask of the data, but was held back by the lack of the speed of the hardware and the software at my disposal. So interestingly, I did have a GPU, and I must admit I bought that GPU to play video games. I threw myself into CS courses because I was so interested in cracking this problem. They only let me into a GPU graphics course at Harvard. Graphic GPUs weren't hot like they are now. You have to remember this is before the deep learning or neural net revolution, and nobody was paying that much attention to them outside of a few specialized fields like if you're doing seismic analysis or computational physics, you might care about GPUs, but not too many other people. And so I took that course and got really excited about the parallelism of GPUs and their potential to transform the analytics space. And I was lucky enough to be able to enroll the next semester in the database course at MIT under professors Mike Stonebreaker and Sam Madden. And Mike Stonebreaker just won the Turing Award. He's done Ingress, Postgres, Vertica. He's done a whole number of pretty influential kind of database and data startups. And so I got excited about the idea of taking an analytic database and combining that with the massive parallelism of a GPU to basically produce something that could not only run SQL much faster by virtue of having tens of thousands of cores at your disposal, but actually power the full analytics pipeline. Because as we know, GPUs are very good at crunching numbers very fast or multiplying matrices by each other, which is the foundation for modern machine learning. And not only that, but they were built to originally render video games. So you can imagine you have a GPU, it's built to render a video game. It can also render lots of data, whether it's on a map or in a graph, and they can do that in a way that you can't with CPU capabilities. And so fast forward today, and our mission is basically what it was, or what the problem I was trying to solve when I first started out in my research almost a decade ago. And that's to make analytics instant and powerful and effortless for everyone. And this statement is basically in juxtaposition to what the status quo was then, certainly then, and to a very large extent still is today. So analytics is still not instant for most people. It's cumbersome, it's slow, it can take hours or days, particularly when the data sets get large. People, because of that, just do surface level analyses. They don't dive in and find the hidden connections in the data. They may be just relegated to static reports. And it's certainly not effortless, right? Every little thing when you're working with big data is really tedious, it's cumbersome. Your system will still crash or run out of memory, just like mine did when I was doing my graduate thesis research. And so that's our mission. And we fundamentally think what's exciting actually is that, you know, as I started down this path and I started building out MapD as my final project for that database course, Massively Parallel Database, which was our name before OmniSci, I realized that many other people had this problem. At MIT, they would send me in front of the industrial liaison group, which would have folks like Procter & Gamble or Verizon or Qualcomm or representatives from the federal government. And people would say, you know, I would show a demo of like 1 billion tweets and being able to query and visualize it sub-second. And people would say, oh, you know, I would kill to have that. My Hadoop queries take hours to run over data sets, not much bigger than that. And that's when I kind of realized that my problem was shared by a lot of people, and that this problem where people want to actually work at the speed of their thought, at the speed of the curiosity, is something that is very broad and very applicable to many different verticals, markets, and use cases. So just quickly about our company, and this may have already been mentioned, but feel very fortunate that this little idea that I had so many years ago has blossomed, and we found market traction and been lucky to partner with some really wonderful investors in the both financial and strategic kind of sectors. So we've taken 92 million funding. We're used at over 100 global orgs, particularly large presence in telco and federal government, but also automotive and retail, pharma, CPG, oil and gas. In pretty much every industry, we at least have some representation, and then certain ones we're pretty widespread. We have a growing open source community around our core open source database. And we've been lucky to receive funding and partnership from NEA, Tiger Global, Google Ventures. And then this is so sad. This slide is actually missing NVIDIA. So NVIDIA is a 4-time investor. So I want to give a shout out to them. I'm not sure how they slipped through, but NVIDIA, InQtel, and Verizon as strategics. And, you know, in addition to investment partners, been lucky, and we can't, of course, mention all of them on this slide. Some are more sensitive than others. But here's just to give you a sense of some of the customers that we're partnering with. You can see the representation in the telecommunications space: Verizon, Charter, Ericsson, Smart, Intel, TELUS, O2. Tutel is an OEM partner of ours. We also have use cases in pharma, CPG, with NVIDIA itself. Many use cases in the federal government sector. And so it's pretty exciting, right? I think, like I said, the problem is shared by everybody. Needs faster insights. If you hear me say something repeatedly, it's just because I think it's very true. Oops. Sorry. Okay. There we go. Apologies. And so why do they need faster insights, right? People are at an impasse. Analytics is at an impasse because now more than ever, it's important to get answers to today's and tomorrow's questions right now on the most relevant data you have, bringing a multitude of data sources together, engaging in multimodal analysis where it's not just SQL or visualization, but it's including machine learning or geospatial analysis as well. But people can't do that, right? They still can't operate at the speed of thought. They're waiting for their machines, just like I was. They have to pre-prep their data to get even acceptable performance. They have to downsample, they have to pre-aggregate, they have to cube their data, they have to do any number of things. They have to pre-join their data to actually get acceptable performance. And that means, you know, what do you do when you have the next question that needs a slightly different combination of data sources? Well, you have to go back to IT, you have to go back to data engineering, and the cycle starts over again, potentially waiting days or weeks to get your new rolled up data set. People are siloed, right? So one of the things I'll talk about too is the value of convergence. So OmniSci, by leveraging the power of these GPUs, as I mentioned, GPUs have the capability to run SQL very fast. They can run, obviously, as many of you know, they can run machine learning orders of magnitude faster than CPU technology. And then finally, they were built to render massive amounts of data, originally for video games, but it's very applicable to a variety of enterprise use cases, including, and I'll talk about this a bit, geospatial analytics. And that goes into the last one, right? So you got billions of points on a map. Your Tableau is not going to handle that, especially in a server client configuration. How do you get billions of points or lines or polygons, especially if they're moving from your server to your browser? It's a very hard problem, and nobody's really cracked it well. But I think that our hardware architecture, hardware-software architecture, gives us a really nice approach on this. So I've talked a little bit about modern hardware, right? You know, the GPUs are, they kind of came out of left field, but they're actually perfect for accelerating data analytics and data science. So they have massive amounts of memory bandwidth. I don't know if people saw, but NVIDIA just released or announced the release of its second version of its Ampere A100 card. The card has over 2 terabytes a second. 2 terabytes a second. Think about that for a second. I think 2 terabytes a second fast, actually. It's pretty amazing. So 2 terabytes a second per card. Now you can have 8 of these on a card. I suspect eventually they'll have a 16 GPU box, which would be 32 terabytes a second of bandwidth, right? Think about all those floppies that some of you may remember. It's an incredible amount of data that you can scan interactively. Second, you know, the rendering pipeline, right? They were built to render video games. I won't belabor that, but that allows us to visualize not just the forests, but also the trees, granular data at detail. People really need that, right? They're not always just looking for rolled-up reports. And then finally, they have a supercomputer level of processing, right? They were, as you know, they have tens of thousands of cores these days, or close to 10,000 cores each. You have many of these on a box. And effectively, they're powering the fastest supercomputers around today. And they're really, really good at doing modern machine learning operations. And so we believe that not only do you want this human in the loop, but you want the human in the loop, the analyst, the data scientist, or the subject matter expert, to be able to get machine accelerated insights, right? So the machine should be able to mine the data, find and explain the anomalies, project out future results, and do predictive analytics. And so you get the marriage of the incredible insight of the human brain with the power of the machine. And so it's not just about hardware, right? So OmniSci, from the beginning, we said, if we're going to leverage, and people are going to go out of their way to get this amazing hardware, but it's not something that's in every data center, certainly more now than it was then. It's now in every cloud as well, but it's not ubiquitous yet, right? We have to match it with the fastest software, right? There's no sense in people investing in this cutting edge hardware if we leave a lot of on the table on the software side. So that was always the premise, and we've done everything. You know, we're a bit obsessed at OmniSci with the idea of performance. And so everything from caching the data as close as we can to compute, compiling our queries on the fly, and so that instead of interpreting a query, we actually have compiled code, which gives us at least probably a 10x speed up over systems that don't do that. And then finally, in situ rendering, you know, rendering right on the chip that we're actually doing the SQL on. So you have billions of rows, you can query that, and without the data even leaving the GPU, you can visualize it as well with the GPU's inbuilt visualization capability. On top of that, and it's not on the slide, we are on the cusp of releasing the ability to run machine learning in situ as well. Just like we do with the rendering, imagine taking the result of a SQL query where you filter out the bad data, the user may be visually defining this view, and then running XGBoost or running a neural net on top. It's pretty incredible, especially the results of having the data, having zero movement of the data. And so it's all done in situ. And the results prove this, right? This is from a well-known blogger, Mark Litwinchick. He's done a number of benchmarks on big data systems. And just to kind of show you or give you a sense, and we actually hear this from our customers, this is not just benchware. You know, you're taking what's seen as a fast data warehouse, so Vertica, and you know, Sam Madden, who's on our board, the other MIT prof, he was a co-founder of Vertica. It's a brilliant, wonderful system, right? Just like Teradata and other data warehouses, they're very mature and great for certain use cases, right? But what it's not great for is interactive speed, right? Even though it's faster maybe than its predecessors, or Spark, for example, maybe faster than its predecessors. On a 21 node Spark cluster, here on a single node, and I wish we actually got the timings here, but we're running this query, I think, in like 20 milliseconds, right? And these are taking 10, 15 seconds. So that shows you that now what was, and expand that, if this is not a billion rows, this is 10 or 100 billion records, all of a sudden you can do interactively what was previously a batch and static process. So to combine it all, so we've talked a little bit about OmniSci in the abstract, but OmniSci is actually a platform, right? It's not just a single product. And so the core of it and the kind of core technological differentiation is in our database, OmniSci DB. OmniSci DB is 100x faster SQL. Even on CPU, because of all the optimizations that I mentioned, we can get significant speedups over kind of incumbent legacy products. And then, OmniSci DB is kind of the engine that allows us to do all this other kind of transformative stuff. So, the whole idea was never like, okay, you can do fast SQL. If a user is typing out their SQL, yeah, it might be faster for some really gnarly queries or matter. But the real killer app is if you're powering a human in the loop doing visual analytics, doing feature engineering, doing interactive geospatial exploration, right? And so that's why going up the stack, the server-side rendering capability allows us to render and visualize massive data sets in a way that even very fast BI platforms can't. And then finally, we needed to surface those capabilities in a user interface, right? So we've had a lot of success powering things like Tableau and Power BI and Spotfire, all your usual suspects from a BI side, and we can make them incredibly fast. But we found that even the interfaces weren't set up to actually use or leverage the power that we had on the back end. It's almost like people were afraid that if we make our interfaces too interactive and make it too easy to cross-filter and brush and link data, then people will actually sledgehammer their backends and they'll bring them down or DDoS them effectively. Well, we didn't have that worry so much, so we wanted to let people loose on their data and effectively kind of explore at the speed of curiosity and make analytics, frankly, a joyous experience. And so that's what Immerse is all about and what I'm about to demo here, as I think demos are better than words. So I want to be conscious of time here. So I know we got started a little late. Before I go into industry use cases, I think I actually will cut to a demo. Great. And before I do that, I'm going to start on something. I'm going to talk a little bit about COVID-19, right? So obviously, tragic pandemic, right? And I think one bright thing, though, is that it's put the best minds to work, of course, on the, the pharmaceutical side, racing for a vaccine on the public health side. But actually, people have been looking at new ways to leverage data to keep people safe. And so here you saw that I switched to an app. This is actually a preview of OmniSci Desktop Edition running on my Mac. And when I said we're fast on CPU, right, and this is what I meant, this is a relatively small data set, 600,000 rows, but easily can handle hundreds of millions as well, right? And that's because we're leveraging all the cores on my Mac. And in fact, we did a benchmark where we showed running query on billion records in hundreds of milliseconds, even on the CPU of a Mac. So that's starting point one. And here you can see the states that are getting, the highest rates of COVID, and so it could be an effective way to actually dive in and kind of visualize this data. But moving on, this is on the laptop next to me. So this is on a Lenovo P53 laptop. It's got a 16 gig GPU. This is 257 million records of location data, right, that we've enriched with various geospatial, like what sort of POI did the user visit, all sorts of data that could actually provide kind of additional explanatory power. And so what you can do here is you can say, hey, I actually want to go in and look at the impact of COVID-19 on commerce. And this is a major thing, particularly for retail and when people looking at, how much, how many people do I need to have on staff? What stores can remain open? What should I provision for what kind of demand? This is a very valuable use case. And so here we can go in and I can click on Walt Disney World, and effectively I can see the exact time when demand went kaput. And this is in March through almost beginning of April in Florida. And if we went forward in time, we could see basically visits start to rebound before I think they had to shut down again, unfortunately. We can see the peak times of visits. All of this is interactive in our system, right? Slightly bigger version. So this is running on my, I like to call it my desktop. So it's a big desktop, right? We have a close partnership with HP. HP, not HPE, but HP, the workstation vendor, and they make some incredible hardware. And as part of the partnership, they sent me this a few years ago with a nice logo of OmniSci on it. It's got two 48 gig GPUs, 384 gigs of RAM, so it's a pretty beefy machine. This is 2.8 billion records here, similar X mode data, and I can do some really nice stuff like, hey, I actually want to see the impact of COVID-19 here on, let's see, let's look at malls. And so I click on that and I can immediately see the top malls. Everything cross filters in real time. Each one of these charts, when I kind of click or cross filter, is issuing a SQL query. And you can go in and you can issue raw SQL. You can also go into a Jupyter environment to do more data science oriented workflows. Here I can see the precise impact on mall visits over time when people are visiting. I could even look at something very different, like hardware stores. And what's interesting here is that hardware stores actually show no impact. So I don't know what it's like in Indonesia, but in the US, in fact, as soon as people were locked in, they started to say, hey, man, I really want to improve my house. And so they started spending more on home improvement, which is interesting, and you can see in the data here. But we can also do things that are closer to contact tracing or hotspot analysis. So if I do, if you know Bluebird, it makes, I think it's Fort Valley, Georgia. Bluebird makes buses in the United States. Let's see if we find them here. Ah, great. So Bluebird Corporation, and they've had major issues with, controlling COVID, like many manufacturers, right? So what we could do is say, what was the impact of COVID-19 on their workforce? So I'm going to lasso here. So just an approximate kind of footprint. We could actually look and see the buses. We could switch to a satellite view. And so now I've gotten down to 33,000 records. And what I'm going to do here is I'm going to zoom out. And I want to look at where these people went after the original shutdown here. Let me actually put all others here. Okay, there we go. And so here I'm at Bluebird, I'm looking and I can see, that there's sharp drop off, and this is actually when they shut the plant down, right? And then they got permission to open. I think they subsequently had to shut down again. So I'm looking at this and I say, well, where did all these people go? Can we see, in fact, that if there was a hotspot or an outbreak at Bluebird? And one of the things I can do a deeper form analysis here, right? So I'm taking this data and actually I'm going to build a cohort on it and say all the people who went to Bluebird plant, I'm going to do a cohort to basically look and say, where did the people in that filter, where did they go? And immediately I can see general medical and surgical hospitals is the 5th top category here. And so I can do this pattern of life analysis. And you see 2 spikes here. I don't have enough data here to dive deep in the stats. This is more suggestive, right? But we've actually done quite a bit of work around COVID-19 with both commercial and federal partners because it's a major problem. And this sort of analysis, you can quickly see, oh man, people visiting this certain type of store actually went to the hospital or to the physician, or you can combine it with other contact tracing techniques. And this is the power of big data at work, right? Saving people's lives. And so we're really excited to be a part of these efforts. And finally, session timed out. Okay, one last demo, just to show you a sense of the scale. And then I know we're running short on time. 11.6 billion records. This is US shipping data. This is less germane, but this is a public demo we have. So you can find our website, 2009 to 2015, US Coast Guard. And so remember, every one of these queries is actually basically, as I drill in, right, and I start brushing here, these queries are coming back in tens of milliseconds, maybe 100 milliseconds max. And that's how we can be so interactive on it, right? So again, you can see the queries here in the right-hand side. Why we're able to allow people to kind of explore data at the speed of curiosity. You look 68 milliseconds, 86 milliseconds. And effectively, none of this is pre-aggregated or downsampled. This is 11 billion records on a few servers, and we're allowing people to kind of query that data and visualize it interactively. Furthermore, and this is, I spoke about this a bit, the rendering capability, there's no way that you could send 11.6 billion records from your server to your client, right? And we can do that because we're actually rasterizing it, or we're rendering it on the GPUs, right? On the GPUs of the server, we're running the SQL, rendering it, and then sending a compressed image back to the browser. But to the end user, they can still hover over it, get metadata. It feels completely like it's in the browser. And so if I wanted to, I could say, I want to actually see what, tankers are doing at this time. And I'm going to zoom into, there's a lot of tanker traffic, zoom into any particular time. And I'm going from 11.6 billion records to 103,000 records. I've gotten down to 26 boats. And now we're down at the minute level. And I can actually brush here, and we can kind of see these boats move across the waters. So when I said you can see the forest, you can see all the data rolled up. And if you find any anomaly, it could be a cyber forensics use case, it could be financial fraud use case, it could be a security use case. You can actually drill down and explore that in real time. And furthermore, you can get that data. And if we wanted to, we could look at any individual boat, see what they did. It's very powerful in how it combines the interactive visual analytics with the SQL and data science workflows as well. So with that, I'll just finish up quickly here. So OmniSci, again, it touches many different industries and verticals, and we're very, very proud to work with incredible partners like Abscindo, because I think the power of our platform combined with the expertise of people who know various verticals and use cases, right, has been incredibly powerful for us. And so whether it's telco or financial services, federal, automotive, utilities, or energy, right, I think accelerated analytics can make a tremendous impact by allowing people to get the answers and insights on the data that they have now, not the data they had yesterday or last week, in a way that they've never been able to before. And I did the demo. And just thank you again to Abscindo. It's been incredible working with you all. Thank you, Pak Rene. It's been an honor to meet you and work with you, and we're excited about all the things ahead. And thank you, everyone in the audience, for taking the time to attend.
Okay, thank you very much, Mr. Todd Mostak, for such a clear and exciting presentation. And as a token of appreciations, symbolic, we would like to give the appreciation like this. Thank you, Mr. Todd Mostak. So we are still expecting for you to join the panel session at 12 o'clock. So please join later on.